Thank you. Okay, all right, now we're going to look at the new material from chapter 7. Okay, now, all right, we just got done talking about logarithms and exponential functions. All right, so what we're moving into now is we're moving into equations that have rational or fractional work where there's algebra in both sides of the fraction. Okay? There's algebra in both sides of the fraction. Now, what do you know about fractions that's important? Are you allowed to divide by 0? No. And so one of the things that happens in the domain for x, it cannot be a value that makes the denominator 0. Okay? So if you look at this problem right here, this example, it's a fraction, right? It's x minus 3 over x squared minus 2x minus 3. If you factor this, and that's what we're going to talk about a little bit today, if you factor this, it ends up being x plus 1, x minus 3. All right, so the first thing you have to do is say, can x equal negative 1? The answer is no, because that will make the denominator division by 0. So x cannot equal negative 1, and x cannot equal 3. That's how you start. Okay? Now, what we're going to find is if the binomial, right, variable plus a constant, if the binomial is by itself in the denominator, that's going to become an asymptote. I'm sorry, what are we doing here? This is backwards, these two are not the same. Okay, never mind. The numbers are the same, but this is different. This is different. You see these two? All right, I'm sorry. I thought they're the same. So here, the vertical asymptote will be where the denominator has a binomial, but there's no binomial in the numerator. If there's one in each, they'll cancel, so they'll simplify, and it will become what's commonly called a hole. H-O-L-E. And they call it a what? Removable discontinuity. Right? But it's a hole in the graph. Right? So here is the hole in the graph. Why is there a hole at negative 1? Because we have two binomials right here that cancel out. Okay? There's an asymptote at 3. That's right there. So that means it will approach 3 but never touch it. So one of the things that's going to happen in chapter 7 is that you're going to begin to look at these graphs. The key is, after we factor, if there's the same binomial top and bottom, you have a what? Starts with a H. Hole, right? Removable discontinuity. Why is it removable? Because it canceled out. All right, but we already knew from the start that it could not equal 3. And then the other one is where there's just 1 in the bottom. That will become an asymptote. And what you do is you would put a dotted line, and you know it's going to approach it but not cross it. Okay? Pretty simple. Those are important definitions, but that's all they are, is definitions. Okay? All right, so then we look at factoring. And this is what I told the SAT practice class. This right here is the same material that we're going to talk about in SAT practice. So for some of you, this is going to be, it'll be new. This is the first time you've seen it in a while. Okay, conjugates and differences of squares. Okay, what's a conjugate? All right, a conjugate has same numbers, different sign. What's a conjugate?
Same number, different sign.
Same number, different sign. So when it asks for conjugates, same number, different sign. Now here's what happens. When you have two conjugates, this times this is the first. That'll be the square of AX. The last number is going to be this times this, which will be negative b squared. But the inside is positive ABX, and the outside is negative ABX. Positive and negative cancel to 0, so you only have two terms. Okay, now let's look at an example. Rather radical example. Okay, so the first thing I want to do with this was a square. So what was the original number? 7x, right? So 7x and 7x. Okay, we wouldn't write it like I did, would we? So under, oh wait, yeah, you don't have this, do you? Okay, so under this is actually 7x, and this is 7x. All right, now what about this? It's what? Square root. 8, right? So I have an 8 here, and I have an 8 here. Now, to make them conjugates, what do I have to do? Plus and minus. So plus 8 and minus 8. Okay? Now, had you been given these, it would have been simpler. You would take the square root of that and the square root of that, right? And put a minus sign in between it to change it. Oh, I'm sorry. Square both of these to be able to get back. Okay? Now, all right, so that's the difference of squares. Now, why is that important? Remember, this right here?
Yes.
If that were a difference of squares, then you'd have to put 2 conjugates down there. That's the reason for going through this. All right, they're going to give you something that's like this, and you're going to have to change it into binomials. So if it's a difference of squares. Now, sum or difference of cubes. All right, this is algebra 2. All right. Only a difference of squares works here in the real number system. Here, now watch, x plus y. What do you see here? X plus y. Okay? What do you see here?
X minus y.
What do you see there?
X minus y.
So, we're going to take the cube, a binomial of the cube that's exactly the same sign. Now, then we're going to take square and then a minus, the opposite sign. And then a square and a plus, so it's the opposite sign. And what will happen when we multiply these out, the plus xy and the minus xy will zero out, and we'll just have x cubed minus x squared. And in a longer class setting, you would have to prove that several times so that you're really happy with it. But I'll tell you this is, if you think about it, if you've got this as a cube, you do the same value, and then you square the outside, multiply the two together, and change the sign. So that some things will subtract out. That's the reason for it. Okay? Any question on that? That's a memorization thing. All right, now. C, completely factor common constants and common variables. All right, as you try to simplify, the first thing you look for is to see if each term has the same factor or has the same variable, so you can get it out first. And then what's left, you're going to have to work probably with some sort of factoring, because you'll have a trinomial. Okay? Now, product sum splits the middle term. I'll explain that in a second. Now, here's something that it's an academic exercise. The discriminant must equal a perfect square if the binomials are going to be rational. Because if you take b squared minus 4ac, if that number is a perfect square, then you can factor it. If that number is not a perfect square, then it's going to have a square root, and the only thing you can do is use quadratic formula, but in a factoring problem, they're not going to give you a quadratic formula answer. Does that make sense? So if the directions are factor completely, then you should be able to factor that trinomial into 2 binomials. And one of the ways you can figure it out is to take the discriminant, and you know that the square, let's say the discriminant was 16. Then it's going to be some number plus or minus 4. All over 2a, right? So you can actually find it that way. Okay, now this is the important part, I believe. Okay, now I'm going to explain something that when I taught algebra in high school, this was the part that most students could not pick up. And the reason was because when you started and this was a 1, all you did was worry about that last number, split that last number and make your, it doesn't work that way when you have higher degree problems. But it's simple. Okay, so here's what I want you to do. I want you to write 20x squared plus 39x plus 18, and then leave some room. Okay, because here's what happened. Where did this 20 come from? It came from multiplying this number times that number, didn't it? Okay, so what are the possible factors? Well, I know that 20 is 4 times 5, so I have a 2, 2, and a 5 I've got to put in one of those two blanks. Right? Now, it could be 20 and 1, it could be 4 and 5, or it could be 10 and 2, but I've got to put the 2, 2, and the 5 in one of those two blanks. Now, where did the 18 come from? 2 times 9, which means I have a 2, 3, and a 3, and I have to put those in here somehow, and when I add them up, they have to add up to 39. Now, I don't have a prime number here, so I have to guess. So what happens if I guess 2 and 10? If I guess 2 and 10, then I'm going to have 10 times something, and 2 times something has to equal 39. That won't work because 10 times something and 2 times something are both even numbers. So that means I got to split the 3. I have to have a 3 and a 6, otherwise I won't get an odd number. Okay, so that's the first thing. So I'd say 3 here and a 6 here for 18. Now, then I have two choices. I just found out that 10 and 2 don't work, so I've got to either try 5 and 4 or 4 and 5. And it turns out that 15 plus 20, I'm sorry, 24 plus 15 is 39, and so there are the 4 factors. So it becomes x, or 4x plus 3 times 5x plus 6 are the 2 factors, binomials, of that original try. Okay. Now, in my experience, this method is the easiest way to try and figure out what binomials exist. Okay? And the key is that we're going to make this, anybody know what these numbers are called? These are called prime factors. And one of the reasons that you were supposed to learn prime factoring in 7th and 8th grade is so that when you got to Algebra 2, you could prime factor the number to be able to do the simplifying into 2 binomials. And so if you didn't do prime factoring, then you don't know where these numbers come from. Okay, that makes sense? All right, now is that a little bit clearer? Okay, now let's go to another problem, which is even more weird. Okay, now, so here's my problem, and it is 30x squared plus 95x plus 50. Now, I'm going to talk to you a little bit about something first, but just given this, what numbers equal 30? 6 times 5, right? But 6 breaks down into 2 times 3 times 5, so that's 30. What about 50? Isn't it 5 times 10? Mm-hmm. So it's 5 times 10. So now those values have to add up to 85. Or 95, excuse me. In order for them to add up to 95, I got to have a 5 on the end of one of them. So that means I need an odd number times a 5. So that means I'm either going to break that 5 or that 5 out. Right? And it turns out that 15 times 5 is 75, and 75 plus 20 is 95, and so they break out this way. Okay? And so I have 15x, and then plus 10, because these are both positive, and then I have 2x plus 5 will equal that. Now, here's the thing in completely factoring. Do you notice that that original number has all 5s? It's a factor of 5? Okay, then what I should have done is factored 5 out. And so that makes this 5 times 6x plus 19 plus 10. What's 6? 2 times 3, and what's 10? Now they have to add up to 19. Well, again, in order for them to add up to 19, I got two choices here. And that is 6 and 1, or 2 and 3. And the same thing, it's either 5 and 10. And so by a quick guess and check, I end up with 15 plus 4 is 19. And so the full thing will be 5 times 3x plus 2 times 2x plus 5, but there'll be a factor of 5 on the outside. But even if you didn't see it, you can still factor it.
Right.
Okay? All right, now let's see you try one. Okay? We're going to take 18x squared plus 27x plus 10. Now, when I first saw these two, I thought, oh, maybe I can get a factor of 3 out. But the last number didn't help me, did it?
Yeah.
All right, so therefore, it's only going to be a factor of 1 out there, so it really wouldn't change. Okay, now what are the factors of 18? 2 times 9, right? 2 times 3 times 3. Factors of 10?
5.
Okay, you break them down so that you get here, you get 27x. Figure it out. It's called guess and check. Put them someplace and see what you get. Again, if you will not practice this skill, this section is going to kill you. Because you've got to get these binomials in order to be able to cancel things out and find out what the graphs look like. I didn't change these numbers here. While you're doing that, I'm going to do some editing. Okay, can I move this page? You working on it? Okay. So it's cutting and pasting, right? Okay, anyway, find them. You try it? No, you can't do it in your head. You got to do guess and check. So you got to set it down. Seriously. All right. So what's the first choice? All right. I'm going to try this. I'm going to try 6 and 3. Okay. Now I have to end up with 27. That means if I put a 5 over there, I'm dead meat because that's already going to be.
Yeah.
Right. And that's going to be too much. So let me try a 2 here and a 5 here. That gives me 12 plus 15. And I lucked out on the first shot. See how simple that was?
Yes.
Right now, what would have happened if I'd have switched the 6 and the 3 around? It might have taken me 2 chances. If I would have used the 2 and 9, I would have found out very quickly that there was no way to use a 2 and a 5 and end up getting 27. So sometimes you get lucky and it works out on the first time. Sometimes it takes several. All right. So you see what happens? So what are the 2 binomials? It's 6x, because all these are plus, 6x plus 5 and 3x plus 2. Now, this would be one side of a fraction. It might be in the numerator or denominator, and then you would have another one that you would factor, and then you'd have to cancel out the ones that match, and then leave whatever's left is the answer in simplified form. That's one of your Algebra 2 skills. All right? Okay, so, all right, now, this is nice. This is actually problem 2 on 340, so this is part of your homework. Okay, same thing. Okay, so what do we have? We have factors of 12, which is 4 times 3, but because this is minus, I've got plus or minus issues, I have to subtract. And then what are the factors of 15? 3 and 5. So, you got to break them apart, you got to create a 12 somehow, and then figure out what's going to end up to be 179. Anybody know what 12 times 12 is? 144, right? So, the two numbers, I gotta put a 12x here and a 1. Because that's the only way to get up to 179. And then you have to figure out what the other number is. Please try it. You're so smart, you should be able to do this instead of just having it be a timeout. Has to be a 12, that has to be a 1. Alright, now, so what choices, if I put a 5 here, how much is 12 times 5? 60. That's nowhere close. So it looks like I'm going to have to put all 15 in here. That's the only two choices I have. Right? And so let's see what happens. What's 12 times 15? No, it's not. It's 180. But 180 subtract 1 is 179. Okay? Now, you see that if you know it's factorable, right, when you did the guess and check, as soon as I put a 12 here, I know I can't split them because there's no way I can get high enough. So I had to keep them together. Okay? Had this number been different, you could have started with the 12 and then had a 5 here. That would have been 60, subtract 2, which would have been a 58. I could have had a 58x in the middle, and then the 5 and 3 would have split. Okay?
Yes.
Right now. I hope that you're beginning to see that there's a way to attack these problems which will actually make them doable without you having to look them up on the internet and say, factor it for me. Okay, now I got one more that's from your homework. Whoops, no I don't. I thought I did. Oh, this one. This is 340. This is number 18. That first one we did is problem 18 on 340. And then this other one was problem 20. I think I said 2. And so it's 18 and 20 from your homework. Okay, so now the last thing I want to talk about is called offset polynomial multiplication. Okay, one of the things that happens if you had a binomial, right? Some people were taught you take the x and you multiply the other x, and then you take the x and you multiply the constant, and then you take the constant and multiply it by the x, and the constant multiply it by the constant, and then you take the two like terms and add them together. Right? And with only a 2 by 2, that works fairly quickly, although there's a faster way. The problem is, if you had a 4 by 4, you're talking about 16 multiplications. And you want to have that thing all spread out like this and then have to try to find out which ones are matching? Okay, hard to do. So that's what this problem does. 1, 2, 3, 4, 1, 2, 3, 12 different products. But what we're going to find is because this polynomial is in descending order, and this polynomial is in descending order, is that we're going to offset and the powers will line up, the like terms will line up. So when you take 3x times, or 3x squared, 3x cubed times x squared, what do you get? 3x5, right? And then 3x cubed times 4x, 12x4. And then 3x cubed times -3, -9x cubed. Now, so that's the first number. The second number does not go over here. When I take -2x squared times x squared, I get -2x4. I don't put it here, I put it over here. So they're lined up. And then -2x squared times 4x will be -8x cubed, and it's automatically lined up. Then -2x squared times -3 is positive 6x squared, and it's now on the end. And when you continue doing that, they all line up. And so now, when you do the adding, you just add your like terms. That comes down first, 12 minus 2, 10. And this is -17 plus 5, -12. And this is 26 subtract 7, 19. And these two are both negative, so that's 43. And then the 21 on the end. There's nothing else to go with it. Okay. If those things were all laid out in a row and it'd take 2 lines to get them all in, so you'd go crazy trying to make sure you got them all done right. All right, but if you offset, and as long as these are polynomials that are in order, those will automatically line up. Some of the more difficult ones you might have to move it around a bit, but does that help? All right, so that's a skill. Again, that's a skill unto itself. They're just wanting to see whether or not you can multiply them. Okay, and we have reached the end. So let's get your textbook out and let's look at what assignments you've got. All right, you turn to 323. All right, now, see what I got my hands in. P of x divided by q of x is the same as using f, a function. They talk about one function that they're calling p and a different function that they're calling x, and they are set up like a fraction. That's all that's what that means. It's not something else that you need, right? But that's how they're determining. So whenever you see f of x, it's talking about a function where the changing variable is x. Well, what's the name of this function in the numerator? It's called p. And what's the name of this one? Q. Now, I could have done this. And have the same thing. Only they just choose for academic sake to use P and Q. Okay? Now, so then turn the page. And what they're asking you to do in 324 is to plot this on a graph. So you're going to replace the x with 0 and plot the results. And replace the x with 4, 5, -1, -3 and plot the results. And you're going to try to figure out what that graph looks like. If you have a graphing calculator, you can put that in the graphing calculator and it'll show you what it looks like. Okay, so 7-1 is just substituting and putting into a graph. Now, what happens in 7-2 is a little bit of change. And what you're going to find is that the graph, we've already talked about this, the graph is going to approach the 3, because if you see in the problem after it factors, what binomial factors out? The x plus 2, see how they'll cancel? So if you remember, that's the whole. Where they cancel, that's a whole. So there's a whole at -2. But there's an asymptote at positive 3. So it does not cross the line of x equals 3.
Right.
So it's going to approach it. Now how do you know whether what it's going to approach like? Instead of using 3, use 2.99. And then use 3.01 and see what the values are. And if one is high and one is low, you know that's one thing. If they're both approaching high, then you know it's something else. What it looks like. Okay, so that's 7.2. Now all of that is just trying to get you to work on 2 problems that graph 2 different equations. Because you're going to do number 2 and number 4. Okay? And then section 7.3 is on conjugates. All right? How are conjugates different? One's positive, one's minus. The values are the same, the signs are different. And so you're going to have to factor out, and then turn to page 334. I'm sorry, 330. See those fingers at the top of the page?
Yes.
All right. Use offset. Use offset multiplication. What I showed you, don't do that. That right there will drive you crazy.
Got it.
Okay. But see, do you notice that it's that's the 4 by 3? Right, or whatever it is, right? And using offset is the best way to do that.
Got it.
Okay, so that'll solve that. Now, completely factoring. This is where we're starting to do practice. Okay, so on page 333, the first thing you're going to do is you're going to determine what the multiplication is, right? And like in problem number 4, we know the first term is going to be x squared, right? What's the last term in problem 4? Negative 14. If you write down the x squared, leave room for the middle term, and write down negative 14, those 2 multiplications do not change. Now, what's on the inside? Negative 2x. What's on the outside? Positive 7. What's 7 minus 2? So then there's a 5x in the middle, and you can write the 3 of them down without having to do the 4 multiplications because you're smart enough to do that in your head.
Right.
Okay, so let's look at 6. First term. First term is going to be x times 2x. How much is that?
2x squared.
2x squared. You write it down. Now we're going to skip. What's the last term? Negative 6 times negative 7. 42y squared is the third term. Now what goes in the center? All right, inside is negative 12 and the outside is negative 7. What's negative 12 plus negative 7? Negative 19y in the center. You can do those binomial multiplications by doing first, last, which are one and done, and then inside, outside of your head. You can do almost all of them, or even if you had to do negative 19 plus 7, or whatever it is, you can throw that in the calculator. You should really whip through these.
Yeah.
Okay, now, all right, now, when you get to 22, on page 333, now you're doing your offset. That's your offset multiplication. So 22 to 40, you're doing offset multiplication, and same thing with the rest of them down that page. Now, problem 36. What problem do you see there? All right, 36. You're going to take the first 2 and you're going to multiply them together like we did at the top of the page, problem 4, and then you're going to do offset with that answer times the third one.
Gotcha.
Okay, so that works. No problem? Now, when you get to 44, you're factoring. First one's easy. Factors of 20 that add up to negative 9. What's factors of 20?
Add up to negative 9?
Add up to negative 9. I mean, negative 4 times negative 5. So it's x minus 4 times x minus 5. All right? Now, what we were doing starts on the next page, page number 46. Because you have to break the 2, but you only have one choice. And then you have to break up to 70, but have a difference of only 4. Okay? In 48, you have to break up to 10 and a negative 1 so that the difference is only 3. Well, I know that one. What are factors of 10?
1, 10, 2, 5.
2 and 5, and 2 and 5 are 3 apart, aren't they?
Mm-hmm.
So that one's going to be pretty quick. Okay, see how those work? All right, now when you get to 64, difference of squares. So give me the two conjugates, square root of both. 64. Reuben, 64 on page 334. Give me square root of both sides. What's square root of x squared? And the square root of 16. Give me two conjugates. X plus 4, x minus 4.
Yep.
All right, next one. 66.
5x.
5x plus 3, 5x minus 3. See how fast those are?
Yes.
They're not hard. Okay, all right? So that takes us through there. Now, the instructions tell you to skip page 335.
Okay.
That, because you're doing calculator work, there's no reason for that. And so that leaves you the splitting in 7-4, which is the last thing, and we started that. So this is going to take you some time to finish. All right. All right, struggle with it, but get better at it.
Okay.
Okay?
Thank you.